So actually, let me restart this. Since this is, yeah, because there's people gone. That's really ugly on this background, but oh well. So now, she was just asking me, do we remember how to factor perfect cubes? It's how many terms times how many terms? 2 and 3. Yes, so 2 terms, 3 terms. The 2 terms are always what? Yeah, uncube it. A minus B. If this is a minus, you put a minus. If this is a plus, you put a plus. Yes, you square the A. It's both of them, but what sign? You switch the sign. That's plus. And the back is always a plus. And it's got to be B squared, because you got to make B cubed. And that'll do it. So that would be how you would do like 2 and 3.
So the 3 terms always have pluses?
If it's an A cubed plus B cubed.
And it's plus and then minus.
Yes, exactly.
The opposite.
It's A plus B, then it's minus AB. Okay, and obviously a question like that's going to be multiple choice, which is the right way to factor it. So I of course will also list the method most people try to do it with. It's wrong. That will be one of the wrong choices. Yes. Not a single answer as C.
Don't give her ideas, you idiot, because then she's going to fill us in some way.
Should use the chances of us
Okay.
guessing the
I don't,
probability.
for the most part, sit there and physically think about which letter I'm going to make as an answer.
I like to do patterns.
And then I go back through, and then I just, if I think I do have too many in order, I just cut and paste them around into different orders, just randomly scrambling them. So they're,
I like to spell things. I like to have
So
like
what you're saying is you never have two questions in a row with the same answer. Like
oh no, I wouldn't say that. But like if I see a whole page of the same letter, which I once accidentally did, then I went back and scrambled some of them because that was not good.
you should have further it off and see what your students did.
Well, the first time it was okay. That actually tends to freak people out because they think they're wrong.
Yeah.
Like ABC, isn't it back and forth?
Oh.
Yep.
Okay, so my first big question was synthetic division. Synthetic is easy, but this morning they needed a refresher. Are you okay with doing the ones on here, or you want me to invent something else? Yeah. This would be like number 5. Synthetic was the one that you had the little box and some numbers written out beside it. Anybody remember how you got the numbers that go in the box? Yeah, you do something, yes, with that, but the actual number in the box is controlled by what? The number on the bottom. Do I put a positive 2 or a negative 2 in the box? Because this is x minus 2. In the box, you put the opposite. You put positive 2, as if you solved it. If you solved x minus 2, you would get 2. Then, how did you get the numbers that go out to the side here? The whole idea of synthetic division is you have no variables. You get to do all numbers.
5 minus 4.
What coefficient is on x to the 5th?
1.
You have a 1 x to the 5th. How many x to the 4th do you have? 0 x to the 4th. How many x to the 3rd?
0.
Then negative 2x squared.
And then
0 for the x's. And then a negative 24. So you're pulling the coefficients off, and you have to leave zeros for the missing terms. Now, usually the big problem is remembering how do I get it to start.
here, you guys drop your 2 down, and then you go 1 back to the minus. I don't really remember.
You don't drop the 2, you drop the 1. Yes. The 1 comes down, and you end up then with a 1 on the bottom. Now, once you got something on the bottom, anything on the bottom gets multiplied times the box. So 1 times 2 is 2, and you put it in the next column and add. So 0 plus 2 will be 2. Now, times it by the box is 4. Add down is 4. So anything times below the line, you times it by the box is 8. Add down is 6. Times the box is, add down is, and last but not least, times the box is 24. Add down is 0. Why is that good news?
That means there's no remainder.
There's no remainder. You like it to come out to be a 0 on the end because you don't have a remainder then. Now the question is, when you go to write the final answer, it's down here on the bottom. These are the coefficients on the final answer, but what power of x do you start with? If this one was to the 5th, and you just divided by x, so now you're down to the 4th. You're 1 less. So that would be 1x to the 4th plus 2x cubed. And since they're all positive numbers, you keep putting plus signs. Plus 4x squared plus 6x plus 12. Synthetic is pretty easy.
How do you write it with the remainder again?
Okay, if there had been a remainder, say the remainder had come out to be negative, you can't see that. If the remainder had been negative 3, then on the end you would have put minus 3 over what you're dividing by, which was x minus 2. So just like you would take when you have a remainder of 2 and you put it over, you're dividing by 3, you get 2/3. Here we get 3 over whatever we were dividing by. Sort of rings a bell? Okay, you'll actually discover I didn't put everything on here that I could have, because I could have also bugged you that long division, but I didn't. Whatever I wrote below the line, I took it times the box. 1 times 2 is 2. Add down. 2 times 2 is 4. Add down. 4 times 2 is 8. Anything below the line, you times by the box. And yes, it really does have its uses. You use it a couple of different places in pre-calc.
Yeah, but what's pre-calc used for?
To solve big, nasty equations that you can't currently solve by hand.
Calculators.
Calculators for.
You can't, your calculators won't solve them.
The calculus.
My calculators won't do. But you don't always get to use those, and we have to learn some problem solving and some techniques.
So in our job, they won't allow us to use calculus.
I got mine's still pressed test.
Oh. We need to hook up one that isn't.
One like number 9.
Okay, so now I want to look at 6, 7, 8, exponent rules. When you add powers, when you multiply powers, when you subtract powers. Are we good with those, or I need to run one of 6, 7, 8?
Can you do one, please?
Do 8.
Do 8?
Yeah, one like that. I don't understand.
I can't possibly do all. We won't get anything else.
Well, you could, well, do whatever you've already did it one time, Miss Harvey, might as well do it again. Actually, wait. It tells you how to work it out on the back. No.
Yes, it does tell you. The answers tell you how to work them.
Somebody wasn't listening.
Because I know there's no way I can show you every possible thing we've done. And I would like to think you've remembered some things.
Only several.
Yeah, my name is
Alright, this is like every exponent rule in one chunk.
Yeah, heck yeah.
Wow.
Where do you start?
With the number left.
Is this number 8?
With the numbers.
Mhm. With what numbers? There's lots of numbers on there.
No, there's more than 4.
You have to deal with the exponents on the outside first.
Yeah, that's fine.
So you distribute it in?
And when you distribute it in, you add or multiply.
Multiply.
When you have power to another power, there's not a base underneath that power, you multiply. Okay, so that becomes 2 to the 24th, because remember, you never change the base. Never change the the base, never change the base.
One more time.
So, that means my A's are gonna be to what? A to 12. Keep multiplying by 3, you'll have negative 9 and C to the negative 15. And then, take it to a power, you'll have 2 to the negative 14th, A to the 6th, B to the positive 14, and C to the negative 2. Okay, anything I need to do to the bottom? Yes, anything to, what's 1? The whole thing is 1, yep. Anything to the 0 power is 1, so that whole thing is gone. We like that. So then, this other quantity I just need to copy down. Now, what's the next step?
Distribute the exponents.
What do you mean distribute?
Up and down.
You need to get the top all combined into one set of terms first. So if I start multiplying the terms on top, what am I doing to their powers? I'm adding powers. And I'm not changing the base, so it stays 2. Okay, I got 24 plus negative 14. 2 to the 10th. A to the 18, if we add it. B to the, negative 9 plus 14 would be positive 5. And C to the negative 17. And then, of course, the bottom is just still sitting there. Then, last but not least, it's the up-down thing.
Up, down.
You have to end with positive powers. It was in another world.
Negative.
So yes, I'm going to move the negative 9, because I want it to be positive, I'm going to move it up. Give me black, something else. So when I bring negative 9 up, it'll become a positive 9, which means I have 2 to the 19th. So let me go over here, that won't went off the board. And then A's, which way do you want to move your A's, up or down? A's go up, so I would take the positive 9 that I have here, and I would subtract 9, which is A to the 9th then. B's which way? Up as well. So the negative 1 would become positive 1, which is B to the 6th. And last but not least, the C's. And they need to get a positive, so yep, they've got to go downward. C's come down, makes that plus 17, and you now have C to the lovely 23rd power. And there is your simplified expression. You've got to keep your powers positive. Yeah, well, I had to combine the A's. If I took the 18 down, I'd have to go 9 minus 18. Okay, rings the bell? Before we sign up? Alright, 9, 10, 11, root land. So I'm talking about how do you break down roots, how do you multiply
Is that a good
roots.
place to stop?
Oh, I probably am. Yeah, let me stop now.